Okay, year 8, so this video is a follow-on video from your graph work that you'll be doing today. And I thought it would be easier to show you how to do some further processing rather than just show you pictures of it. So here's a graph that I've drawn. This is of exactly the same results and the data that you've got from your challenge. So I've just laid mine out like this. I've figured out the averages of all my times and my results that I had, and I drew a little table on the side of my graph here, so you can see the time column going down there from 0 to 10 and the average temperature going from 17 all the way to 96.5. So hopefully these answers here will match up with what you have on your averages as well. Once I've got the averages, I'm then going to plot them on a graph. I'm only plotting the averages to start with. Along the bottom, I've got time along the bottom. You just can't see that on a graph there. If I just move it up a bit, there you go. You can see now that I've got time along the bottom a bit more. There it is. So time in minutes, and I've managed to go along here with 0, 1, 2, 3. It did fit really well actually, going all the way along to 10. This is on our x-axis, and then on our y-axis up here, I've had to shorten it a little bit. In hindsight, I probably would have chosen to have done the graph portrait rather than landscape, but portrait I had to kind of make it work. So I started from 10 there and then worked my way up to 100 there. As I said, if you flip the graph around the other way, doing this in portrait probably works a lot better. Then I've given myself a title, so a graph to show a change in temperature over time when water was heated in a beaker. And you can see I've got all my units on each of my scales as well. Then I've plotted my points, so that was really simple. That was just finding the time, so 0 down here, went up to 17, so I went 0, found 17 and put a little x there. So that was really easy to do. And then I did the same for every single result. There is one on here, I think it's 7, where I was just off to the left here. That should be a little bit more across to the right, so it should really be more about there than there. And then when I was finished, I needed to decide how to show a trend. So I can do that either with a dot to dot, so joining up the points, or a freehand curve sometimes. You'll see data that looks like it's curved. But on this instance, I've decided to use a line of best fits. And that's basically a straight line that you draw with a ruler and a pencil. So you can see if I put this on here. And the idea is with a line of best fit, you want to try and go through as many points as possible with one straight line. So with one straight line, I managed to go through the middle and always touch lots of those points. Now, a line of best fit is very good for two reasons. One, it shows a good trend in your data. It shows my data's going up. We call that in maths and science a positive correlation. But it also allows me to make predictions with my line of best fit as well. So for example, if I wanted to know what the temperature of water would be at, say, 5.5 minutes as opposed to 6 minutes, using a line of best fits, I can make an average, can't I? So what I can do, and here's your first further processing technique, is I can take my ruler and I can find 5.5 minutes, which is there. And I might just do this with a pencil instead of a pen. So I can do this, just a dashed line all the way down, all the way from the line of best fit. So see what I've done there? I've gone from 5.5 minutes. Now normally I'd have to just guess whereabouts this might be, but because I've got the line of best fit, I then know what to do. I can then take that there, flip it around 90 degrees and draw another dashed line going this way. And it ends up over here being about 65 degrees, see? So even though I don't have a result for 5.5 minutes, I can have a guess using a line of best fit. Because I've got that positive correlation line, 5.5 minutes would equal out at about 65 degrees. And if you look in your results, 5 minutes is 59.5, 6 is 67, so 65 would fit between those two values, wouldn't it? So it kind of works. The next further processing technique, so you could do that by the way a couple of times. You could have a guess as 2.5 minutes, 5.5 minutes, or 8.5 minutes, just using these line of best fit. The second tip of further processing is to plot something called a range bar. And I'd like you, if you get done on this graph quickly, to try and do this for every single one of your points. Range bars for this basically show us the closer the range bars are, the more reliable and accurate your results are for each time that you took them. So for example, in order to do this properly, today, you need all the results in front of you. So I've only got the average ones there. So on my computer here, I'm just logging on, I can see here. So let's take a time and a temperature. So for example, let's go for, what should we do? Let's go for 8. So I'm going to start with 8 over here, okay? So that was the average at 8 minutes. That was the average temperature, 83.5. But if I go back and look at my results that I'm looking at on my computer screen now that you should have on a handout, it actually says that there were 2 results for 8. It says there were 2 results. I'm just going to write them on here. You don't need to do this, but I'm just going to write because you can't see them. It said the first result was 82 degrees. I'm just going to write 82 there. And then the other result was 85 degrees. Okay, so they're both from 8. Hopefully you'd agree. You can see those on your own results. Now, we just plotted the average, didn't we? That point there for 8 is just the average, which is 83.5. But now I'm going to ask you to plot these 2 extra results as well. And here's how you do that makes it look a bit different. So first of all, you plot the lowest. So 82. So 82 on here. What was the average? 83.5. So 82 on my rule. I'm lining it up. I'm looking over here, roughly finding about 82, which is probably about there. I'm coming all the way across to where my point is. So about there. Okay. And instead of plotting an X this time, I'm going to plot a straight line. Like that. Hopefully you can see that. There's just a little straight line there that looks like that. And then what was the highest? 85. So now I'm going to do exactly the same again. So 85 would be about there. And again, I'm going to draw my little line like so. See? So now you've got the X sandwiched between those 2 lines. And then I'm just going to join them together like that. And there you go. There's your first range bar. Now, why that's really important is because if I just use this dead space down here to just show you, you ready? Imagine this was a range bar, you ready? It looked like this, okay? That's pretty good. The closer together those lines are with the X, the more accurate your data collection was. But imagine you had a range bar that looked like this, okay? Imagine you had a range bar that looked a bit like that. See the difference? So what that space is saying is when you collected your results, your bottom one was quite low, your second result was quite high, and then in the middle they've had to kind of find an average point. Whereas the closer together your data points are, the more accurate and reliable your data is overall. So what I'd like you then to do is to go and plot a range bar for every single point, okay? So go and plot one for that one, for that one, for that one, for that one. If I look at my results on the screen, they all look pretty close. Like at temperature 0, it was 18 and 16. 1 was 25 and 22. 2 minutes was 36 and 34, so that should be a small range bar. So they will all look quite small. You know, when you've plotted them all, they're probably all going to look very tiny, like that, aren't they? Okay. As you go down and you see them like that. So good luck. That's 2 ways you can do a bit of further processing on your graphs.